Hey, good afternoon, guys. Thanks for joining us at Biodiversity Conference. Hope you've all got to enjoy yourselves with the other attractions we have outside. Please silence your cell phones as we're recording right now. Our next speaker here, Mike Kauffmann, he teaches math and science at Fortuna Elementary, and he teaches a class on science education here at Humboldt State. He recently published a book, Conifer Country. It is a natural history guide to the Klamath and Klamath Mountains, which emphasizes conifer diversity and has some really cool hiking trails and some hiking trips you can find in there. We really encourage you all to buy a copy afterwards. He'll be signing copies at the table out front. His website is really cool too, conifercountry.com. Has some similar information. So with no further ado, Mike Kauffmann.
Well, thanks for coming. I want to thank Bobby for facilitating this weekend. It's a pretty amazing thing he's putting together. He's got some help, but pretty cool stuff, so thanks, Bobby. So I'm feeling a little bit rusty because I actually haven't been in the field very much in the last 4 months. I had the birth of the book back in May, but also the birth of my first child, and didn't really adventure as much this summer, so I'm feeling slightly disconnected from the conifers, except for the redwoods and some of the coastal stuff. But I'll warm back up, and we'll get into it here today. And we're going to go on a journey across the landscape. I'm going to look at 100 million years or so of conifer evolution, and then how that really relates to Northwest California. So why am I crazy about conifers? Well, it's a manageable means to comprehend Klamath Mountain biodiversity. So through the eyes of the conifers, you can, I think, because there's only 35 to 38 of them, I think it's something you can grasp and understand our landscape, our very complex landscape in the region. They are harbingers for climatic change for millions of years, and they're basically deep time survivors. And I think they're absolutely gorgeous. So another grand reason to talk about them. So what is a conifer? Well, if we look way back 425 million years ago, plants became compatible with land. The first land plants were things like horsetails, ferns, club mosses, which reproduced with spores. And we still have some of these, or at least relatives of these in the redwood forest. A couple horsetails and lots of ferns, obviously. But these plants began to develop vascular tissue they could start to grow up. The gymnosperms, which include conifers, followed soon after, about 365 million years ago. And then angiosperms, the flowering plants, came about around 140 million years ago. So gymnosperms and angiosperms, these are the seed plants of the world. And the seed was pretty cool because it helped promote dormancy. And this opened up new pathways for plant distribution and evolution. I'm not really going to get into a lot of that, but it was different than the spore. It was an advancement for the plants. Gymnosperms, their seeds form on a variety of structures. We're all familiar with cones, especially here in the northern hemisphere, but they remain naked after they're mature. And angiosperms' seeds are generally enclosed in something. So in the Mesozoic, 250 to 65 million years ago, this was the heyday of the conifers. There were 20,000 species or so that evolved across that time. But about 65 million years ago, somewhere 100 to 65 million years ago, angiosperms began their adaptive radiation. For various reasons, the planet warmed, grasses became compatible with certain animal species, grazing mammals, things like that. And angiosperms established in the low to mid latitudes, which they still dominate today, and they began to co-evolve with various animals, specifically with pollination, and then also with seed distribution. So concurrently, in the last, say, 65 million years, gymnosperms have declined to only about 1,000 species left on Earth, and angiosperms have expanded to over 300,000. It's probably way more than that. So they're in a lot of ways, gymnosperms are relics. They are sort of a dying breed, so to speak. And this decline of gymnosperms and concurrent expansion of angiosperms is really one of the most significant phytogeographic, meaning distribution of plants, processes, distribution over space and time in the history of plant life on Earth. So, if we look at what's left on the planet, we have 4 extant divisions of gymnosperms. There's cycads, which are mostly tropical. There's about 250 species, so about a quarter of the remaining gymnosperms are cycads. There's these crazy things called gonadophytes, and we're familiar with, we may be familiar with the ephedras of the California desert. I think we have 7 or 8 or 9 species in California, only about 70 worldwide. The ginkgo, there's only 1 species left, native to the mountains of China. Obviously, if you're familiar with landscaping, they're somewhat popular in North America as a landscape plant. There's one in front of the Natural History Museum, as a matter of fact. There's probably a few more on campus. And then the conifers. There's about 630 species, and this is going to be our focus today, not all 630. So, Conifer Wow. A couple more things to really wow you here. They're exclusively wind-pollinated, except for one. It's called a welwitschia in Africa. There's an insect that pollinates. But everything else, the other 999 or so species, are totally reliant on wind. They often grow where soils are suboptimal. Now, we live in an exception here in the redwood forest. The soils here are, well, for the most part, pretty nutrient rich. So there's a little bit different story going on here coastally. But higher elevations and other places across the west, suboptimal conditions. Most conifers, or I think all conifers, have a mycorrhizal relationship with fungi, but this is something that's poorly developed or absent in many angiosperms. So that kind of helps, especially on these poor sites. It helps the conifers be able to fix nutrients and whatnot. And generally, conifers are restricted to higher elevations and latitudes, the exception being, like I said, coastally here in the temperate rainforest. And then here's the coolest thing, I think. Less than 1% of all plant species are conifers, pretty much way less than 1%. But they cover by area 30% of the Earth's forested land. So where they survive, they do a pretty darn good job of it. And some serious conifer wow for California. We have the largest, tallest, and oldest living thing. It's all conifers, and they all grow in our state. And we get to hang out underneath one of them right here in Humboldt County. All right, so if we look at where gymnosperms live across the planet, this is, you can see we've got some hot spots, obviously in Northwest California, also in the Sierra Madre Occidental of Mexico. A lot of those are pines. We're at a crossroads up here, and we're going to get into that in the next few slides. But basically, half of all conifer species are on the Pacific Rim. And in California, Oregon, and Washington alone, there's 65. Or somewhere around 65. All these numbers are, can be debated if you argue for certain species or subspecies or variations, and also how you define the region. But in Northwest California, we've got 32 to 38 species. So it's a hot spot globally. So conifer families of the world, just to kind of you don't really need to read what these are because I'll get into it. But if you see just globally how things are distributed, we're going to focus on these top 3 because these are the families in Northwest California and the Klamath Mountains: Pinaceae, Taxaceae, and Cupressaceae. So the pines, firs, hemlocks, larches, yews, cypresses, junipers, redwoods. And you can see that pines and, if we zoom in a little bit here, pines and yews are exclusively northern hemisphere. There's a few exceptions where they get south of the equator in the South Pacific. And Cupressaceae are the most widely distributed family of conifers in the world. They pick out certain spots in that southern hemisphere that they still do well. So we're going to look at these conifers and how they fit into the landscape of the Klamath Mountain region. This is I believe this picture is where the holy grail of conifers are in Northwest California, probably my favorite place in the world. This is the Siskiyou Mountains. My son's middle name is Siskiyou. I love it so much. It's where I fell in love with my wife and where I fell in love with conifers. So this is the Siskiyou crest in the Siskiyou Wilderness, and that peak in the background is Preston Peak, which you can see when you take off from our airport. It's always my favorite. Get the left side of the plane. You can kind of, when you're flying to San Francisco, you can see it out there in the distance. So. All right, so here's the Klamath Mountain region as I define it based on rock type. Southern tip is down here in the Yolobole, North Yolobole Peak. This boundary from North Yolobole all the way up to Wichipec is South Fork Mountain, which we can see from out in the dune forests if you look back to the east. And then it extends all the way up north of Grants Pass. Actually, that's way north of Grants Pass, the Umpqua Basin and whatnot, up into Oregon. But if you look around this region, you see that it's a melting pot of the Cascades, the Modoc, and the Great Basin, the Central Valley, the Sierra Nevada, and the Coast Range. So we're really at this crossroads here in the Klamath Mountain region. So there's a central location, as I've said, along the Pacific slope, and that has allowed species over millions of years to also be able to travel up and down that slope as climates have changed. And it's this habitat mosaic, as I've mentioned, and all of these biotic regions help define the Klamath and the flora. There's also this interesting complex soil. This is just one example of this, but we have serpentine soils, serpentine geology, and I go into some gory detail in my book, and there's other great books out there that explain this, but it allows for this evolution on microsites. So certain conifers, certain flowering plants get on this soil. Other species don't compete very well there, and they flourish a little bit better than other species, and they evolve oftentimes into new species on these substrates. And this is the case for a few conifers. There's also complex climatic conditions. It's historically been moderate, but we also have this varied landscape that creates these microsites for plant evolution elevationally, latitudinally, and longitudinally. Specifically, if we look out here in the Scott Mountains near Mount Shasta, you can see that there's a significant amount of rain that is deposited there, and there's certain species of conifers that, specifically the Port Orford cedar, that survives right here, and then it survives all the way along the coast up to Coos Bay. So it's got this disjunct population because of these climatic conditions. So this is, you can download this from my website, but this is a little schematic that I made that I had a lot of fun doing. It really helped me to picture what's going on. But if you look here, it's kind of a cross-section from Crescent City to Redding. So if we start on the coast, obviously we were familiar with the redwoods, the hemlocks, and the Sitka spruce, but as you begin to move west, things dry out a little bit. And on the west slopes of the Siskiyous, species such as Port Orford cedar survive. At the high peaks of the Siskiyous is a southern range extension for Alaska cedar. We'll look at some pictures of that in a little bit. Then you have this dissected terrain of the Klamath Mountains and the big areas in the central Klamath of the Marble Mountains, Russian Peak, Trinity Alps. And as things dry out, pines begin to appear. High elevation pines like foxtail and whitebark pine live at the tops of these sky islands. And we also have some endemic species like the Brewer spruce, as well as the Port Orford cedar, that have a pretty restricted range now in the region that used to be much more widespread. So little schematic to give you an idea of this varied landscape and how these plants have really fit very specific sites within that landscape. All right, so on my website, I have the handout, and hopefully there was enough for everybody. If not, I put a little, if you're way into your little mobile devices, you can download these as well and all this other stuff. But we're going to take a look at this table to begin to paint this picture, and we're going to look at 7 or 8 of these species specifically with some range maps and see how they help define the region. So on the right side, I've got the geographic distribution of 32 of these conifers. You notice those little arrows there, and that is a graphic to help you show, or to help you see whether they're at the southern extent of their range, the western extent of their range, the east or the northern extent of their range, or if they're just, common across western North America. So 16 of the 32 conifers in the region are either at the northern, southern, or western extent of their ranges, which I think is pretty darn cool. So it's this ancient meeting ground, really. It's a place that these plants have found the perfect little niche that sort of mimics where maybe they're more common in another area. And then if we look at the endemics, we have 3 near endemics. The Brewer spruce is endemic to the Klamath, and the Port Orford cedar and the siskiyou cypress grow within the Klamath and on the fringes of the Klamath as well. So 3 of 32 conifers can basically be found nowhere else on Earth. And I think whatever this says to you, I think it's pretty cool, but 9 of the 32 reach a record size within the Klamath. So obviously 3 of those are the endemics, so that data's a little skewed, but at the same time, it's pretty cool that the conditions here help some really darn big trees to grow. So the region has 3,500 species of vascular plants and up to 38 species of conifers. And that's why I think conifers are a manageable means, because it's really hard to learn 3,500 species. All right, so we're going to focus first on the pines. And obviously the pines make up a large percentage of our conifers. And I think that by looking at their story, it really tells the story of a lot of the other species that are around here. So I've also included a cladogram on the backside of all the pines in the world and made some little marks on it. Nerd out on it if you want, but I just decided to throw it on the handout because I'm a teacher and I like visuals too. So, but we're going to dig into a few of these sections and subsections of the pines. But first I want to look at the world biogeography of Pinus. So Pinus are ponderosa pine, anything that has a pine cone that we're familiar with, and we'll look at a few pictures soon. But here's the world distribution of pines. There's like one spot south of the equator that one pine grows. I forget what it is. Basically, they love the northern hemisphere. And that's because of some deep time evolution. So they arrived in the mid-Jurassic about 175 million years ago. But now currently there's depending on who you talk to, about 111 species. And that's half of the species in Pinaceae and 20% of all gymnosperms. So I'm sorry, that's not right. It's 20% of all conifers. Anyway, so here's if we break down where Pinus fits within Pinaceae. Picea are spruces, Pseudotsuga is Douglas fir, Abies is fir, and Tsuga is hemlock. All of these occur within the Klamath Mountains. All right, so the Pinus Prototype, why do they do so darn well around here? Well, they are light demanding. So they typically like dry sites that are open and there's less competition. So this is a picture of a Jeffrey pine on serpentine soil. You can see there's not a lot of competition for the Jeffrey pine, and it is happy as it can be there. They're fast growing. And they often regenerate as even-age cohorts following landscape scale disturbances like fire. Knobcone pine is a great example of that. There's a fire ecologist on campus that taught me that last summer. Pretty exceptional to see an even-age stand of knobcone pine. Thank you, Dr. Kane. So if we look at the Triassic Pinaceae, so in the Triassic, conifers evolved, like I said. This is what we think continents looked like, landmass looked like. Pinaceae ancestors diverged around this time, and Pinus began to evolve in the Jurassic and the mid-latitudes. The earliest known pine was around 130 million years ago, somewhere in those mid-latitudes. So it sort of has this genetic stock that likes this subtropical sort of environment. In the Paleocene, the planet warmed, and Pinus migrated north of the 65 degrees north, or stayed around 2 degrees north. So there was this divergence. So pines sort of went in two directions. And this was a big separation. And we're going to look at some ancestors in the Klamath that separated out at this time here in a few minutes. In the Eocene, there was another warming, several more warming periods. And there was, in the Eocene, at certain periods, there were no deserts, tundra, or polar ice caps, and the subtropics went all the way up to 70 degrees north. And there was also this interesting population that popped up in what would soon become the Rocky Mountains, which led to my favorite group of pines. And we'll see that here in a few slides. In the Oligocene, there was decreased rainfall 35 million years ago and increased seasonality with fluctuations of up to 25 degrees Celsius in a year. So that's going to sculpt some pretty hardy plants like the conifers. It's going to help some of those conifers. And there was a complex climates going on, the ice sheets, volcanism, mountain building, and this led to radiation of pine. So if a mountain range pops up, a pine could potentially settle in that area and become restricted and lead to a new lineage. So, whoops, I thought something was going to pop. The Miocene, there we go. And most modern pines can be traced to ancestors in the Miocene as climate warmed but stayed dry. So, just a quick summary, and we're going to dive into the Klamath here. Angiosperms favor, in general, high nutrient sites. And gymnosperms have this tolerance for poor soils and extreme conditions. And the angiosperms themselves favor high nutrient sites for many reasons, including increased net photosynthetic capacity over the tougher leaves of the conifers. Conifers invest a lot more energy in those needles than most angiosperms do. There's always exceptions, but. All right, so evolutionary limits. There's patchy distribution because of habitat types. Pines can tolerate a broad range of environments from subtropics to subalpine because of that divergence over the last 40 million years or so. And then Pines and Rappaport's rule. This is pretty interesting. Lower latitudes, there's just more competition. There's like 10,000 species of plants in certain areas around the equator. So there's just more competition for pines. So therefore, pines and most species in general have smaller ranges closer to the equator. And pines are, of course, going to be restricted to the higher elevations near the equator. In the mid to upper latitudes, though, pines have a much wider range. If you think about lodgepole pines across Yellowstone, as an example. And they therefore became better dispersers due to climate fluctuation. So as glaciers pushed the lodgepole south, they were then trained to be able to spread back as those glaciers receded. And the Klamath then has representatives from all these evolutionary lineages. We have broad swaths of certain pines like ponderosa pine forest in certain areas, but we also have very restricted mountaintop sky islands with whitebark pines. And then the Pleistocene to the Holocene, we're going to look at how the subsection Contorta, which is, we're familiar with the lodgepole pine, fits into this, this evolutionary happening, so to speak. So at some point, there was a migration north after the glaciers retreated, and the subsection Contorta sort of spread out. Some of them went east, some of them went north, some of them went west. And if we look in Florida, there's Pinus clausa, which is a relative of our lodgepole. In Virginia, or in the Piedmont area in the southern Appalachians, Pinus virginiana. Pinus banksiana spread out across Canada, and it actually hybridizes with lodgepole up here in Canada. And then we were left with Pinus contorta. Now, it's quite a complex story about Pinus contorta in the West, and it's argued, are certain examples that we find subspecies or variations. So let's look at what could have happened at the end of the Pleistocene. This is my little graphic to illustrate. So let's say Pinus contorta was spread out in these areas at the end of the Pleistocene. The Ice Age ended, they moved back north, and this is what we have today. So if we look at subspecies contorta lives along the coast, and we'll zoom in on Northwest California here in a second. And then we've got the Sierra lodgepole pine, which meets the Rocky Mountain lodgepole pine somewhere in northern Oregon. But you'll notice even down in Sierra San Pedro Martir, there's still a little relic population. So that says that these trees were definitely further south than they are today. They've moved north. So if we move in on Northwest California, we'll see a very complex story going on. Down in Mendocino County, there's these cool pygmy forests. If you've never been down there, Hans Jenny Pygmy Forest is really a cool spot to go. There's a cypress there as well, the pygmy cypress. But there's this variation of lodgepole that grows on these soils that are really compacted, and it's hard for the roots to get down in and get nutrients. If we get up near Humboldt Bay, I hope everyone's been out to the Malheur Dunes since they've opened up the new trail out there. Absolutely spectacular beach pine forest. If you haven't been, it's your homework. Get out there. And there's these small pockets of the beach pine all the way up into Del Norte, which is where the Sierra lodgepole pine in the Klamath Mountains sort of meet here in Del Norte County. And this has been historically referred to as the Del Norte Mystery, because the pines up in the Smith River National Recreation Area, the lodgepole pines, they don't really look like either one. They're somewhere in between. So it's probably a hybridization bridge between these two populations. But you can see these isolated pockets of lodgepole. There's big swaths of them up here in the Scott Mountains. If you've ever been up on the Pacific Crest Trail in that area, you walk through extensive lodgepole pine forests. But the further you move to the west, the more restricted and smaller these populations become. Here's some examples of what these, this is the Sierra lodgepole. This is taken in the San Gabriel Mountains of Southern California. And this is the Rocky Mountain lodgepole in the Pasayten Wilderness of Washington. And then if we look regionally, this is out in the dune forest, a couple miles from here. And this is the Del Norte Mystery with this strange reflexed cone, sort of serotinous. And there's several theories as to why that could be the way it is, including maybe a fire dependency. Maybe there's a relationship with crossbills in the absence of Douglas squirrels, so that the cones then produce a thicker scale, so the crossbill has a harder time getting in there. So it's this convergent evolution with the birds. But the mystery's never been solved. So sounds like a cool thesis. If you want, somebody can talk to me about it. So anyway, let's look at this back in the Eocene, this group of pines that evolved in the Rocky Mountain region. And this is the section Paria, which includes the pinyon pines and the foxtail and the bristlecone pines. So here's a little phylogenetic breakdown of those, and we're going to just look first at Balfourianae, which is the Rocky Mountain bristlecone, Great Basin bristlecone, and the foxtail pine, which we have in the Klamath Mountains. So again, let's say the end of the Pleistocene. This is my little theoretical drawing. Maybe a little bit more of a widespread range. Climate warms up a little bit, and they become restricted to mountaintops. Here's Northwest California. We're going to zoom in on that in a second. But you can see there's two disjunct populations of the of the foxtail pines, Southern Sierra, and then the Klamath, and then the Rocky Mountain bristlecones, and the Great Basin bristlecones. So if we look at Northwest California, not too many populations left. There's some extensive stands in the high elevations of the Trinity Alps. If you've ever been up Thompson Peak or some of the highest peaks in the Alps, you've seen them. There's also some really cool stands in the Red Alps up out of Trinity Center. The southernmost populations are in the Yola-Boles. This is South Yola-Bole, and that's North Yola-Bole. And then northward, the northernmost population of foxtail pine is on Lake Peak. You can actually drive up there. There's a fire lookout. A cool lady that has been up there 50 years. She's been at this fire lookout every summer. She is a character. So if you want to go talk some high elevation foxtail pine stuff, she'll be there every summer. So So you know, it's kind of cool. You can see where these are the spots that foxtail pines grow, because these are the spots that are above 7,000 feet. So if we zoom in on the Red Alps, I like this picture for various reasons, but one is you can see this is a south-facing, this is 7-Up Peak here, the flanks of 7-Up Peak in the Alps. This is south-facing serpentine, and it's covered with, well, not covered, but peppered with foxtail pines. If you look over on the granite in the background, these are all firs and hemlocks. Foxtail pines, they don't really like the north-facing slopes because they like sunlight, and the hemlocks and firs don't like these south-facing serpentines because of the soil, for one reason. So this is that mosaic, that juxtaposition I was talking about within the Klamath Mountains. This is in the same area. This is above Stewart's Fork, and I love that tree. So. If we look at the southern Sierra Nevada, things look a little bit different down there. The peaks are all pretty darn high. This is the Mineral King region. This is actually up near Alta Peak. Last summer, this was, I think, middle of June, and I got snowed on up there. So it was a little bit different summer last year. A lot more snow in the Sierra. So they're just slightly different. That's why they're subspecies of each other. So then if we look at the lineage of pine that comes from this, in the Eocene being isolated in the far north, we've got several representatives in Northwest California, with Pinus lambertiana, which is the sugar pine, and Pinus albicollis, and Monticola. Albicollis is the white bark, and Monticola is the western white. Here is the range of Pinus albicollis. And this is the species that is becoming threatened every year as climate changes, especially in the Rockies. Vast swaths of these trees are dying because of bark beetle infestations. Maybe a little bit of white pine blisterus, which is also an invasive species, so to speak. And then in the Klamath, you can see we've got a few little pepperings of white bark pine, and they extend south into into Kings Canyon in the Sierra. So if we zoom in on Northwest California, these are even rarer, more rare than the foxtail pines. There's a little population up on Box Camp Mountain. They do pretty well over near Mount Eddy. This is along the Salmon Mountain crest in the Russian wilderness. And then they like the high Alps, as do the foxtail pines. But really, they're not synonymous with foxtails. Whitebarks need even a little bit higher elevation, 7,500 feet or above. This population on Box Camp is only 7,300 feet. And we're going to take a look at a couple of pictures from last summer, or 2 summers ago up there. I guess it was last summer. So here's the summit. This is a really nice, healthy tree, south-facing slope. It's mixing in with some foxtail pines. This is the Boulder Peak area. Over the hill from there is Etna. But if we turn the other direction, there's a lot of mortality of these whitebark pines. And this is the only, I believe I've been to all the populations of the whitebark, and this is where I've seen the most mortality. There were a lot of these trees had passed away in the last few years, maybe even a little bit more. So this is an example of really the ecological amplitude has been reached for this species. There's nowhere else to go. They can't go up anymore, so they're not doing so hot on this really, comparatively low site to the rest of where they appear in the Klamath. And then if we go over to the Scott Mountains, this is near the summit of Mount Eddy. Trees seem to be doing pretty well. Beautiful windswept giant bonsais, I like to say. So then we'll look at one last group of pines that evolved more in the subtropics. And we're going to zoom in here on the subsection attenuata, which are the closed cone pines. Almost exclusively in California, or at least within the California, well, no, almost exclusively in California. So Pinus muricata, this is the bishop pine. They love the coast. Today they're not more than 2 miles inland. And they are much more, we have this really disjunct population here at Patrick's Point, and then they show up again down near Fort Bragg. But you can see they extend all the way down into northern Baja and also out on Guadalupe Island. And I forget the name of this island, but they're on a couple islands off the coast of Baja. And if we look, I went to this population in Baja a couple summers ago. It's a desert. So this is the subtropics. Well, it's not quite a desert, but it's shrubby, coastal, gnarly little trees. We look the other direction, dry river. And then if we look at our population in Northwest California, they're competing in the middle of a rainforest. So I think that's pretty cool that this tree, because of the soils at Patrick's Point, has been able to hold on there. And they do compete with, there's actually no redwoods right in Patrick's Point, but they do compete with Sitka spruce, depending on the soil type there. So just to wrap up Pinus, they're ecologically adaptable because deep time has sculpted this genetic refinement across variable latitudes and complex soils. This is another picture of the Siskiyou Mountains, some serpentine soils, Jeffrey Pine Forest. So a couple more examples of conifers that sort of fit this southern, western, northern description. We'll look at the Brewer's spruce, which is our endemic spruce. Used to have a much wider range across the west. Fossil records from Nevada, Oregon, now restricted from Iron Mountain in Oregon to near Weaver Valley. Lookout near Weaverville. There's a little population over in the Castle Crags. But basically they've found their little niche, that they generally like north-facing slopes. Not always the case, but north-facing slopes and kind of open terrain, maybe places that fire have a hard time getting because rocks restrict, a lot of open areas with rocks that fire can't really get in because there's not stuff in the understory. I don't think we really know the whole story on Brewer spruce yet, but those are some of my postulations. And they're just stinking beautiful, I think. I mean, look at that. It's like tinsel, you look at their branches, it looks like the perfect Christmas tree. And this was an interesting place in the Red Buttes Wilderness where it looks like a pretty fire-prone area, and the theory is Brewer spruce generally avoid these type of places, but this one looks happy and healthy. And we saw some recruitment after a fire maybe 20 years ago, where the young seedlings were coming in next to knobcone pine. This was right along the Pacific Crest Trail, so kind of interesting ecology here. So if we look at Cupressaceae, here's where they live around the world. So they do get into the southern hemisphere, but we've got some great representatives, about 10 in the Klamath region. And we're going to look at 2 right now, the Alaska cedar and the Siskiyou cypress. Siskiyou cypress is a near endemic, and the Alaska cedar, we've only got about 10 populations, 11 populations in California of this species. So here's its range. There's also a couple disjunct spots. This is the Aldrich Mountains of eastern Oregon. But you can see we're pretty disjunct down here in the Klamath. So let's zoom in and let's see where they live. The southernmost stand is near Elk Hole, which is at the end of the Go Road up out of Orleans. Populations near Summit Valley. This is the Devil's Punch Bowl area. If you've ever, that's a pretty popular hike. You can see them around both lakes. They do really well around Preston Peak. And then a couple of scattered stands with the right habitat in the northern Siskiyous. And these are all populations. I actually found 4 of these over the last 5 years. So we still don't know a whole lot about Alaska cedar in the Klamath. If we look at this Kangaroo Peak population, which I found last summer, this is it. This little teeny pocket. It's north facing, stays cool. This is kind of out near the Applegate. This is the headwaters of the Applegate River in the Red Buttes. So it's an outlier, and we need to watch these things because who knows, that's really a small population. So who knows what could happen. I know there was a fire that burned out. This is Kangaroo Peak up here in the background. The Hello Fire was burning around Kangaroo Peak. But just looking at the habitat around this, they're probably protected from fire because of all that rock. But who knows? Something to keep an eye on. Here's the range of the Baker cypress in Northwest California. You can see this is probably, well, besides Pacific silver fir, this is our rarest conifer. Only on Serpentine, with the exception of a few trees around Miller Lake. And if we zoom in on the largest population, this is the Syad-Baker Botanical Area north of Syad Valley. Red buttes in the background. They do really well here. They're very extensive across the landscape, but there again, they're stuck on the Serpentine, so to speak. And that's what the cones look like. And then lastly, the Taxaceae. There's 2 species in the Klamath region. One of them is probably technically not in the Klamath, the California nutmeg, which is endemic to California. We're going to look at the Pacific yew, which across the west has a pretty extensive range. And then you'll also notice within the Klamath has a pretty extensive range. We'll zoom in on that Klamath area. Well, I guess we'll look at the map here in a second. The yew is different because it produces its seed within this berry-like structure called an aril. There's 1 seed per aril. And it's debated a little bit whether or not it's actually in a conifer, but in with the conifers. But for all intents and purposes, it looks like a conifer, and it acts like a conifer. So I've got it in with the conifers. Here we have it in Northwest California and Southwest Oregon, and favors stream beds at lower elevations, but it also favors some of the higher peaks. So if we zoom in on Preston Peak, on the summit of Preston Peak, this is a yew, it's still alive. And into the summer, they tend to get desiccated like this because of intensity of the light. This is a south-facing slope. But it's prostrate, it's growing across real mat-like up in the high elevations. And then if we look on the South Fork Trinity River, we got these big old, often single-trunked, sometimes multi-trunked specimens that grow, that like the riparian, keep their feet wet right in the water. So again, a little bit of variation in the ecology of the yew. So why did I write this natural history book? Well, because I believe natural history is in some ways a lost art, but it's also a primary component of our culture. And I think being a teacher, I've been an outdoor educator and teacher for almost 17 years, I guess, and I see less and less connection with the natural world. Students need, kids need, we all need hands-on experiences that are going to lead to these holistic perspectives. And I think that this book offers a chance to experience the wildest region in the state, a little bit of Oregon too, through the eyes of conifers. And it tells that deep time story. I'd like to thank John. John died last month. This book wouldn't have been anything without him. He's really the conifer guru of Northwest California, the Klamath Mountains. And I'd also like to thank the Redwood Science Project at Humboldt State, my advisor Jeffrey White, and the California Native Plant Society for helping me over the 8 years to write this book, to put it together. So I think it's great. I've gotten a lot of good feedback on it. People are taking it into the field. And they're having hands-on experiences, and we're learning about, I think, the coolest lineage of plants on the planet. So the HSU bookstore is selling them in the back there. It's also available in many stores locally. And some of the other maps, a lot of the black and white maps, regional maps, are in this book. I'm hoping to have another book published next year, Conifers of the Pacific Slope, that looks at 65 conifers of California, Oregon, and Washington. And those are some of those other maps you were looking at. So check out my website and stay in touch. I guess I'll take questions, and I think there's a microphone that, because they're putting this on TV and stuff, so if you want to ask a question into the mic, I'd be glad to take them.
Are the white barks in California dealing with canker rust like everywhere else?
Yeah, there's a new paper that came out recently, and the bleakest look was in the Warner Mountains, which is in extreme northeast California, and probably they're struggling because in southern Oregon and the out in the Oregon desert and the high mountains out there, the bark beetles were able to sort of just make that jump down to the Warners. I'm not an expert on this stuff, but apparently the Sierra is doing okay, and it seems like the Klamath is still doing okay at this point. So it's just something we got to keep watching. And it seems to be that, and somebody can correct me if I'm wrong, but it seems to be that the major detriment is the bark beetle, not quite yet the white pine blister rust.
Hey, Michael, great talk.
Thanks.
A lot of your work has been backcasting. And so if you look forward in time in terms of climate projections, what's coming up on your radar screen as some of the vulnerable conifers? For instance, we already know that Alaska yellow cedar in the northern part of its range is going through an extensive decline right now,
right,
related to snowpack that's been dropping and late winter freeze exposure to the roots.
right.
Redwood may be another one because of declining fog. But can you think of any other species that you would be concerned about? It sounds like maybe the pines are robust to these kinds of changes, but what about some of the other conifers? Anything coming up for you?
Yeah, I went and saw that population of Alaska cedar in the Aldrich Mountains about 4 summers ago, and it's not doing well at all. That's the one that was way out, isolated by itself, and that sent up some serious red flags for me. I'm an optimist. I mean, I think in some ways maybe it's to my detriment. Well, I'm an optimist about conifers anyway. What I hope I see is this maybe refined genetic code of these Alaska cedars, because they're in these isolated pockets, and you figure they've been in these isolated pockets for a long time. So maybe there's this code that says, I can deal with it, it's a little bit drier. I can deal with it with a little bit less snowpack because I've been here so long in the Siskiyous. But maybe that's naive. I don't know. I wonder. I feel like maybe in the short term, 50, 75 years, the outlook's pretty good. Brewer spruce, I've heard stories. We got to plant them in southern British Columbia in the coastal mountains because that's going to mimic the Klamath in 150 years. But I went into the biscuit fire burn in the Kalmiopsis a couple springs ago, and large scale burn across the landscape, but there are these north-facing pockets where 8 Brewer spruce remained, and they'd always been there, and it didn't seem like any Brewer spruce had burned. So I hope the plants know what they're doing, I guess. So redwood's a whole nother mystery, and I look forward to hearing your talk tomorrow, Dominic, about that. Any other questions? All right, well, cool. Thanks for listening, and get out and explore.